NPR. I'm not asking what is NPR, right? Don't think this type of questions, right? So the questions are based on the applications, right? So application in the sense here, the question is there are three letters A, B, C, right? Now my question is, by utilizing these three letters, I need to make two-letter words. Two-letter words. So tell me how we can answer this question. How we can answer for these. So this is one of the application, right? We are utilizing in NLP. We have something called in natural language processing, right? We have something called NLP, natural language processing, right? So maybe the ChatGPT that is fully work with these natural languages, right? So the basic NLP is connected with these counting techniques, right? So maybe if you have a subject called data mining in your third year, on that we will discuss what is NLP. Under NLP, we have something called tokenizations, right? So at that time, tokenization, we making all possible words by utilizing the letters, right? So at that time, you need to know these equation permutations, right? Then only you can find out all the possible combination of words, right? Now tell me what is the answer for this question. You have three letters A, B, C. You need to make how many two-letter words? In this question, right, you cannot duplicate the letter again and again. It means you cannot make a word this way. We cannot make this way. Keep in mind, right? Only you need to utilize two letters and make the word, right? This is a different scenario. I will explain later, right, how we can answer by duplicating the letters, right? So now this type of questions, you have three objects, A, B, C. From these three objects, you need to make two-letter words. It means you need to select two objects from these three objects and you need to make different words. So how many different words you are making? Tell me what is the answer? So you have three letters A, B, C. You need to select two objects, either A or B, A or C or B or C. You need to make words. How many words you can make?
It's for 3p2. So 3 factorial over 1 factorial. It should be 6, I think.
What about others?
6.
Just think and tell me the answer. Then I will explain. Okay, those who find out, can you write all 6 words? Okay, how we can find out? Here we have 3 objects. So n is equal to 3. From n is equal to 3, we need to select 2 objects. np2, right? So np2 in the sense 3p2, 3 factorial over 3 minus 2 factorial. So 3 minus 2 factorial. 3 minus 2 factorial, right? So 3 factorial over 1 factorial. So 1 factorial is equal to 1, right? So 3 factorial means 3 into 2 into 1, 6. 6 over 1. There are 6 words we are make, right? So what are the 6 words? So I will write all 6 words. Check now, right? So AB, AC, right? Then BC, BA, CA, CB, right? So these are the all possible words AB, AC. So it means the first position I am giving for A. Now the first position giving for B. Now the first position giving to C. So can someone tell me is any other letters except these? Can you tell me any other words except these?
No, sir.
No, sir.
So these are the all possible words we are making by utilizing only 2 letters, right? So now I am telling this is permutation. Why? If you look at this one and this one, if you look at this one and this one, both are contain the same element, A and B. The letter A and B are included these two words, but the order of the element, right? The first element here A, here the first element is B. Similarly, if you look at these two, right, the same element, but the order is different, right? If you look at next BC and CB, right, they are the same element, but the order of the element is different, right? In this question, let's say now tell me how many three-letter words I can make. Three-letter words. How many three-letter words you can make?
3-letter word from the possible orders totally.
So it means 3p3, right? 3 factorial over 3 minus 3 not factorial. So that one also 6, right? So we can make 6 words. So what are the 6 words? ABC, ACB, BCA, BAC, CAB, CBA. We cannot write any other letters, 3-letter words, right? Okay, now this is the question without repetition, right? Without repetition mean in the sense, right? Without repetition means we are not considered this like this. The same letter repeat again and again. It is not possible. Then the equation is NPR, right? By utilizing this equation NPR, we can find out the answer when we can find out this answer without repetition. Without repetition means, let's say, if you think about the 3-letter words, we cannot make a 3-letter words A. It means all 3 letters are same. B. This is not possible, right? This is we can call without repetition, right? Without repetition means this one. Right now, I will explain with repetition how we can find out the answer. With repetition, how we can find out the answer. With repetition, how we can find out the answer? Tell me.
For the all possibilities, sir, or selection of possibilities, sir?
Okay, the same question, right? I will explain. You have 3 letters A, B, C, right? You have 3 letters A, B, C. You need to make 2-letter words. 2-letter words with repetition. With repetition in the sense. With repetition in the sense. Let's say A also possible. B also possible. C also possible. This is with repetition meaning. Meaning of with repetition means this way also possible. So how many words we are making? Tell me. Before I explain the equation, tell me with repetition, how many words we are making? Just look at here. Now here we are making without repetition. It means A is not considered. B is not considered. C is not considered. All other combinations are look at here, right? So it means the same, right? AB, AC, BA, BC, CA, CB. With these 6, we can make another 3 AA, BB, CC. That's all, right? Altogether, how many?
9.
9, right? With repetition, we can make only 9 words. Previously, we can make 6 words without repetition. With repetition in the sense, With repetition in the sense, how many words we are making. So the question is, you have three objects A, B, C. You need to make two objects and create two-letter words, right? Without repetition, the equation is NPR. With repetition, you have a specific equation. Before I will explain the equation, now I am telling you what are the all possible two-letter words we are making, including with repetitions. So altogether only we have 9 two-letter words we are making, right? So how we can make the equation? Only we have two positions, right? Only we have two positions, right? Now I will explain how we are generate the equation, right? Now tell me, right? Yeah. Okay, the previous scenario, now tell me, in this scenario, without repetition, right? Without repetition, we have two scenarios. Without repetition, we have two positions. Now tell me how many ways you can fill this first position. You have A, B, C, three letters, right? So without repetition in the sense, without repetition means we cannot use the same letter again. Without repetition, without repeating the same letter in the sense. Now how many possible ways we can choose the letter?
Or 6. Oh,
What
three
about
variables.
others?
Recording in progress.
Okay, how many possible ways? It means what are the possible ways we can fill this first position? This position? How many possible ways? What I'm asking, for the first positions, what are the possible letters you can put?
Three positions.
Three
Three.
positions, right? Then tell me how many positions you can fill the second position.
2.
So this is a multiplication rule, right?
It's
Why
also
I'm
three.
why I am telling this is a multiplication? This is a product rule, right? Maybe this is not a sum rule. Why? The first position selection impact by the second position, right? It means they are interconnected events, right? The event 1, for the first position we are selecting one letter. Event 2, we are selecting second letter for the second position, right? It means if it is a without repetition in the sense, without repetition means if you take one letter for the first positions, we cannot take the same letter again for the second position, right? That is a without repetition. So how many possible ways we can select the second one? Second position?
Three.
Two ways. So that's how we are making 3 into 2 is equal to 6, right? When without repetition. Now tell me the same question with repetition. Now, how many ways we can make the first position? How many possible letters we can put for the first position?
3.
First character, 3. So, with repetition in the sense, how many possible ways we can select for the second position?
3.
3. Why? Let's say already if you select for the first position A, now you can select for the second position also the same letter A. That is with repetition, meaning of with repetition in the sense, if you're selecting for the first letter, also the second letter also you can select the same letter. That is the meaning of with repetition. So previous case, first position 3 ways in the sense, second position 2 ways. Why? Already if you select A, only now we have only 2 letters. So that's why we are consider 3 into 2. But with repetition, first letter we are selecting in 3 ways. Also, the second position also we have 3 ways. Why? Even if you select A for the first position, second position also you have a chance to select the same letter. So 3 into 3, 9, right? So this is how we are getting this 9, right? So first position we have 3 ways. Second position also we can select 3 ways. So 3 into 3, 9, right? Okay, now my now my question is, we have 3 letters A, B, C, right? Now I need to make 3 letter words. Now I need to make 3 letter words with repetition. How many we can make? with repetition, 3-letter words, how many I can create? With repetition,
9.
how many words I can make? Someone tell me the answer. Just think about yourself and tell me the answer.
It's maybe 9.
Previously, without repetition, only we are making these, right? Without repetition, we are only making 6 words, 6 3-letter words we are making without repetition. So
27.
how we can find out this one? You have 3 positions without repetition in the sense, without repeat the same letter, this position 3 ways, second position 2 ways, this position 1 way, 3 into 2 into 1, 6 ways.
For the 3-letter,
3-letter with repetitions, how many words you can make?
27. 3 to the 3, power of 3.
So first
27.
position we are making 3 ways, second position we are making 3 ways, third position we are making 3 ways. So 3 into 3 into 3, 27 words, 3-letter words we are making, right? 27 3-letter words we are making with repetition. So if you look at this one, here 3 to the power 2, right? Here 3 to the power 3. So the common equation, right? If you have n number of objects, right? From this n number of objects, you are utilizing the same n number of objects, and if you make the words, so make the orders with repetition, the equation is n to the power r, right? So if you have n number of letters, from this n number of letters, you are utilizing r number of letters with repetition, then n to the power r is the equation. Let's say here n is equal to 3. You have 3 letters. From these 3 letters, just you need to utilize 2 letters and you need to make the words with repetition, then 3 to the power 2. Similarly, if you have 3 letters, 3 ABCs are 3 objects, just utilize all 3 objects, and if you need to make letter words with repetitions, 3 to the power 3 is the answer, right? So the common equation n to the power r. From the n number of objects, you are making orders by utilizing r number of objects with repetitions. N to the power r is the equation, right? So if you are confusing, I will write all the 27 words.
Excuse me, sir.
Yeah.
For the permutation formula in PR and also the with and without repetition for the NR, all are the same formula method or different scenarios we have to use?
These are 2 different scenarios, right? So the NPR, when we can use, if you are using NPR, right? While you are using NPR, we cannot make, let's say the same example. I have 3 letters A, B, C, right? The scenario NPR, if I want to use, I cannot consider A is a one word, right? It means we are not consider repetitions. Repeat the same letter again and again. That is not possible, right? But if you are using n to the power r, this is possible. A is also we consider 1, right? That is the thing. So you can remember these, right? Depending on the question scenario, you need to decide whether we can use this one or this one.
Okay, sir.
Okay, I will explain with an example, then you can understand, right? Okay, just think about, right? Okay, just think about, we have 3 flags, right? There is a cricket match. Just imagine there is a cricket match. There is a cricket match between Sri Lanka and versus India, right? Just I will explain with a real scenario, right? There is a cricket match between Sri Lanka and India, right? Now we need to host the flag of Sri Lankan flag. We have a Sri Lankan flag is there, right? We have Sri Lankan flag is there. We have Indian flag is there, right? Yeah. Just we have Indian flag is there. Another ICC flag is there, right? We have 3 flags are there, right? One is Sri Lankan flag, one is Indian flag, one is ICC cricket board flag, right? Now we have 3 rods to hoist these, right? We have 3 rods to hoist these, right? This is the question. We have 3 flags are there, right? Okay, okay, now just think about, I have only 2, okay, I forgot this. I will delete this one, right? Now this is the real question, right? I will explain. There are 3 flags. One is Sri Lankan flag, one is Indian flag, one is ICC flag, right? But anyhow, only we have 2 rods to hoist these flags, right? Unfortunately, one is broken or something. Only we have 2 flags to hoist. Now tell me how many possible combination we can hoist these flags. This is the question. There is a cricket match is happened today. We have only we have 3 flags: Indian flag, Sri Lankan flag, and ICC cricket board flag, right? But unfortunately, on that ground there are two flag hoisting rods are there, right? How many possible ways you can hoist these flags?
It's
How many possible ways you can hoist these 2 flags? So this is how your questions are coming. I am not telling whether it's a permutation question or combination question, whether we are using with repetition or without repetition. I'm not telling anything. I'm asking a question. You need to think about the scenario and you can take some decisions, right? So now first thing you need to take a decision whether it's a permutation or combination. Tell me.
permutation.
Permutation. Why? The order
See,
of the flag hoisting is important, right? Which order we are hoisting the flags, right? Either first we are hoist the Sri Lankan flag or Indian flag or ICC flag. The order is must. So if order is mandatory in the sense, this is a permutation question, right? So first you can take a decision. This is a permutation question. The reason is this is a permutation. This is a permutation question. The reason is the order of hoisting these flags are important. So this is a permutation question. Now you have another question, whether is it possible to repeat the same flag here? Is it possible to repeat? So what do you mean by repeat here? What do you mean by repeat here?
like the person have the 2.
The repetition in the sense you are hosting Sri Lankan flag here, Sri Lankan flag here. Here also you are hosting the Sri Lankan flag. Is it possible? Only in the question I clearly mentioned you have 3 flags. Is it possible to repeat the same flag in both? No, right? Because you have only one Sri Lankan flag, one Indian flag, one ICC cricket board flag. So it means we cannot hoist the same flag again and again. It means in both rods, we cannot hoist the same flag. So it means we are not utilizing the equation of n to the power r. So this is how we can approach the question, right? So in the question, they are clearly mentioned they have only 3 flags, one Sri Lankan flag, one ICC flag, one Indian flag. So it means we cannot host the same flag in both roads. So this is the decision you need to make, right? So only you have a scenario NPR, right? You have 3 flags. From these 3 flags, you need to hoist 2 flags, right? So what is the answer for this? 3p2, 3 factorial over 3 minus 2 factorial, 1 factorial. So it means 3 into 2 into 1, 6 ways we can hoist the flags, right? So now I will tell the 6 ways. One, Sri Lankan flag and Indian flag. This is one way, right? With Sri Lankan flag, ICC flag. This is another way, right? With Indian flag, you can hoist the Sri Lankan flag. With Indian flag, we can hoist the ICC flag, right? With ICC flag, we can hoist the Indian flag. With ICC flag, we can hoist the Sri Lankan flag. So these are the all possible 6 combination of hoisting the flags, right? Do you understand?
Excuse me, sir.
Yeah.
For the permutations, the theory says like all possibilities, if we get the questions, we have to say permutation method. But according to these questions, we have from the 3, we have to select 2. So is it, can't we take combination?
So can you repeat the question?
என்ன சொன்னா பெர்மிட்டேஷனுக்கு கம்பினேஷனுக்கு உள்ள வித்தியாசம் வந்து பெர்மிட்டேஷன் வந்து நார்மலா எல்லா பாசிபிலிட்டிஸையும் எடுத்து கம்பினேஷன் வந்து செலெக்ஷன் மெத்தட்ல எடுக்கும் அப்படித்தானே?
இல்ல நீங்க இப்படியே விளங்கிக்கிங்க, ரைட்? இப்போ பெர்மியூட்டேஷன் சொல்றது என்னன்னு சொன்னா ஆர்டர் ஆஃப் த எலிமெண்ட் தான் கன்சிடர் பண்ணுவோம், ரைட்? இப்போ ஆர்டர்ல அரேஞ்ச் பண்றது தான் பார்ப்போம். எல்லா எலிமெண்ட்டும் எடுக்கிறங்கிற கான்செப்ட் இல்ல.
செலெக்ஷன் அப்படி வராது, ஆர்டர் தான் ஃபர்ஸ்ட் பிரியாரிட்டி.
செலெக்ஷன் சொன்னா என்ன சொல்றாங்கன்னு சொன்னாங்க, இப்போ கம்பினேஷன்ங்கிறது செலெக்ஷன் என்ன சொல்றாங்கன்னு சொன்னா ஆர்டரை கன்சிடர் பண்ணாம செலக்ட் பண்றது. ஆர்டர் தான் அந்த எந்த உதாரணமா 10 பேர் இருந்தா காம்பினேஷன் எப்ப யூஸ் பண்ணுவோம்னு சொன்னா 5 பேரை செலக்ட் பண்ற சந்தர்ப்பம், ரைட்? 10 பேரையும் தான் செலக்ட் பண்ணணும் இல்லை, 10 பேர்ல இருந்து 5 பேரை செலக்ட் பண்ணலாம். அந்த செலக்ட் பண்ணக்குள்ள எந்த ஆர்டர்ல செலக்ட் பண்றதுங்கிறது முக்கியம் இல்லாட்டியாது காம்பினேஷன், ரைட்? எந்த ஆர்டர்ல செலக்ட் பண்றதுங்கிறது முக்கியமா இருக்குமா இருந்தா அதான் பெர்மியூட்டேஷன். அதான்
கேள்வியில வந்து இப்ப ஆர்டரை மென்ஷன் பண்ணாட்டி நம்ம காம்பினேஷன்ல எடுக்கணும், இல்லாட்டி அப்படியெல்லாம் மென்ஷன் பண்ணுவாங்க அப்படியா?
இல்ல இப்ப அது ஆர்டரை மென்ஷன் பண்ணணுமா இல்லையான்னு சொல்லி நீங்க டிசைட் பண்ணணும்.
கொஸ்டனுக்கு ஏற்ற மாதிரி.
கொஸ்டனுக்கு ஏற்ற மாதிரி. சில டைம்ல இப்ப சில கொஸ்டனுக்கு அதை மென்ஷன் பண்ணிருப்பாங்க, சில கொஸ்டன்ல மென்ஷன் பண்ணாட்டியும் இதுக்கு ஆர்டர் முக்கியம்னு சொல்லி நம்ம அண்டர்ஸ்டாண்ட் பண்ணணும். ஃபார் எக்ஸாம்பிள், if you are making passwords, right? If you are making password generation type of questions, you need to give the priority for the order of the elements, right? So it means one guy making a password by using this letter in different orders, right? So you are the one decide whether we consider the order or not. If you are making a team with let's say you have 10 members, just think about the Sri Lankan cricket board. There are 30 members, right? From the 30 members, they need to select only 15 members for a match. How many possible ways we are selecting? So this type of questions, you don't need to worry about the order of the element. The only thing we are consider, who are the people included in that 15 member team. We don't think about whether we are selecting this guy first, this guy second, this guy third, likewise. We are not consider while we are making groups. But if you are making some words, some passwords, that type of scenarios, or maybe you can arrange something in a particular order, that type of questions we are consider the permutation, right? So why here I consider permutation, right? Here the order is more important, right? If the order is not important, then it considers as a combination, right? If the order is not important, right? So now tell me, if the order is not important, it considers as a combination questions, right? So what is the answer for these? From 3 flags, 3C2. So what is 3C2? 3 factorial. 3 minus 2 factorial means 1 factorial into 2 factorial. So 3 into 2 into 1 factorial. 1 factorial is equal to 1. 2 factorial, 2 into 1. So I can cut down these and these. So only 3 combinations. So what are the 3 combinations? If you look at here, Sri Lanka, India, this is 1 flag. India, Sri Lanka also the same things, right? If you look at these two, these are two same. If you think about Sri Lanka and ICC and Sri Lanka, right? These two are same. If you think about India, ICC and India, both are same flags, but the order is important. So some questions they are clearly mentioned. You can give the priority for order, which order you are selecting the elements. Some questions they are not telling the order, but you need to think whether order is important or not, right? It depends on the question, right? What about others? Did you understand or not? If you not understand, please let me know. I don't know everyone get this.
Excuse me, sir.
Yeah.
For the combination also, we have the question like repetition and without repetition.
Combinations. Combination, it's not possible, right? With repetition.
Okay.
Let's say, just think about you're making a team, right? From 30 members, you need to select 15 members. Is it possible we can select the same member again and again? It's not possible, right? Did you understand my question? So just think about you have a 30 members, 30 players in the cricket team, Sri Lankan cricket team. If you want to select the 15 members, is it possible we can repeat it with repeated we are making the team? Repeated in the sense you are copy. It means you can clone the same one. It's not possible, right? Did you understand or not? Just think about in your classroom, there are 100 students, right? I need to select 10 students for a competition, right? Let's say there's a student one, maybe Ravi is a student, right? Is it possible I can duplicate Ravi 2 times? From the 100 students, I need to select 10 students, right? So it means I'm making a group, right? So while I'm making a group, is it possible the same Ravi happen 2 times in that group?
No, sir. No, it's possible.
So it's not possible, right? So that's why I'm telling in combinations, we cannot do the repetition again. In that is depending on the question, right? Normally combination we are using making some groups, right? So maybe if you have that type of question, it's possible, right? Normally it's not possible in making groups, right? Don't think too much, right? Maybe if you think about that up to the combined mix, A-level combined mix, that is they have too much complex questions, right? So here we are giving only the basics, right? So maybe sometimes if you are from the physical science background, maybe you have some experience, right? So
Yeah.
up to
Giving
this,
the slide. Rolling
up to
dice. Yeah, that's okay, sir.
yeah, up to this one, just think about normally we are using combination for selecting groups, making groups. So at the time we cannot duplicate. So it depending on the question, right? Don't think that too much difficult questions I will put for your final exams, right?
Okay, sir.
Okay, any questions? Better you can understand some types, then it's easy for you. Let's say the first type without repetition, the second type with repetitions. Now I will move for the third one, right? Third one in the sense, let's say the same letter happen more than 1 times. Then how we can do that? Give me a minute. Yeah, I will arrange the slides. If you're confusing some questions, better you can write all the possible answers. Then it's easy for you to find out the or try to understand, right? Sometimes you confuse, is it possible? So then you try to apply the equation and find out the answer. After that, you can write all the possible combinations. Then you can easily understand, right? Okay, up to now you familiar with two types, right? Without repetition, how we can make the permutation. With repetition, how we can make the permutations. NPR, n to the power r, right? So this is we discussed, right? Okay, this one also we discussed, n to the power r with repetitions, right? Okay, just I will explain the scenario, right? Let's say you have three letters A, B, C, right? Just think about, you have the first scenario, you have three letters A, B, C. From these three letters, you need to make two letter words without repetition, without repeat the same letter, n to the NPR. NPR is the equation, right? The same scenario, you have three letters, you need to utilize two letter words with repetition, repeat the same letter again, n to the power r, right? Now the third scenario, just try to understand the third scenario, right? Let's say you have three A's. Just think about, you have three A's, two B's, one C. This is also possible, right? It means previously you have A, B, C, three letters. Now you have three A's, there are two B's, one C, right? So now how many objects you have? How many objects you have?
6.
6 objects, right? You have 6 objects, but in these 6 objects, A happened 3 times, B happened 2 times, one C is there, right? Now, from these, you need to make six-letter words, right? Okay, I will explain 6-letter words. Only here we are consider utilizing all the objects, right? Then it's easy. So you have 6 objects. Among the 6 objects, there are few objects are duplicating. The same objects 2 times happen. It means the scenario. Let's say there are 2 Sri Lankan flags are there, right? 3 Indian flags are there. Likewise, you have a box. Inside the box, one ICC board flag is there. There are 3 Sri Lankan flags are there. 2 Indian flags are there. So if you take 2 Indian flags, both are same, right? Exact the copy of the flags, right? So this type of scenarios, now you need to hoist all 6 flags, or maybe you need to make 6-letter words. Now you need to make 6-letter words. So how many words you can make? This is the next one. How many words? Hope you can understand. First 2 scenarios, are you clear? Third scenario, the same object happened more than one time. If it is a one time, no issue. If one object included one time, no issue, right? Previous case, the A, B, C, each letter is unique letter. But now there are 3 A's, 2 B's and 1 C is there. Now tell me, by utilizing these 6 objects, how many 6-letter words you can make?
With repetition or without repetition, sir?
You cannot consider repetition here, right? Because already that special characters duplicating, right? Anyhow, it will duplicate, right? So if you have a 3 A's, we cannot say this is the A1, A2, A3 or something, right? All are A's. If you are making a word in the sense, we cannot say this is a A1, this is A2, this is A3. It means whatever the A, they give the same meaning or same words, right?
Oh, it's a 6 factorial over 5 factorial. 6.
Yeah, they, for example, you are making a word CAB. Yeah, CAB. Okay, just think about CAB, AA. We cannot say this is a different A, this is a different A, this is a different A, right? Here we don't think about with repetition or without repetition, right? So in this type of question, right, you have n number of objects, right? Among these n number of objects, some objects are the same objects. Utilizing these all n objects, how many words you can make? How many 6-letter words you can make? You have 6 letters, right? Among these 6 letters, A occurred 3 times, B occurred 2 times, one C is there. Right now, my question is how many 6-letter words you are making?
60.
What about others? 60. What about others? Normally, right, if you are duplicating the letters in the sense, right, let's say, just think about, you have 6 different letters. Just think about, I have 6 letters, right? I have 6 letters, right? These are the letters. A1, one letter, A2, A3. Just think about, this is a unique letter. This is a unique letter. This is a unique letter. A1, A2, A3. B1 is a unique letter. B2 is a unique letter. C is a unique letter. Right? Now tell me, if you have 6 letters, by utilizing all these 6 letters, how many 6-letter words we are making without repetition? Without repeating the letter, how many words we are making? 6-letter words. What is the equation? 6 to the power 6p, 6 permutation, 6 without repetition in the sense 6p6. So 6 factorial over 6 minus 6 not factorial. So 6 factorial means 6 into 5 factorial. So 6 into 5 factorial 120. So 6 into 120 means how many? 720 words, 6-letter words we are making, right? We cannot write all 720. It takes a lot of time. But anyhow, we can make 720 words. That is true, right? When this is a separate letter, this is a separate letter, this is a separate letter. But if you look at this scenario, right? This scenario, the same letter happened repeatedly. It means the A, there are A's 3 times happens, right? Now, we will come to our question, right? You have 6 letters, but few letters are the same letters, right? The A happened 3 times. We cannot say this is first A, second A, or third A. It means, let's say, just think about, from these 6 letters, I can make a word cab. Just think about, for an example, from these 6 letters, I am making a 3-letter word cab, right? Can you tell me, right? Let's say this A is the first A. The second, the same, let's say this is with A1, this is A2, right? But if you hide this A1, A2, both words are the same words. Cab means the same word, right? It will not impact by which A we are taking, right? But the word is same word. That's the thing, right? Maybe we have 3 different A's, but we have 3 A's, right? We have 3 A's here, only 1 B, sorry, 1 C, 2 B's are there, right? If you look at here, we cannot say this is first A. So if you're selecting the first A, this is a different word and different meaning. This is the second A, because of that this is a different word, different meaning. This is a third A, because of that this is different word, different meaning. Anyhow, we are not consider which A we are selecting, right? All three give the same word. Did you understand what I am telling?
Yes, sir.
So it means cap means we are not consider which B we selecting, first B or second B. Only we are making the word cap. That's all, right? Even if the letters more than one time occurred, but it give the meaning of only one word. Cap means one word, this one. So this type of questions, how we can find out, the what are the possible words we are making. The equation says if you have n number of objects, n factorial divided by, now we need to find out what are the letters they occurred more than one time. So A occurred 3 times, the letter A occurred 3 times, the letter B occurred 2 times, right? More than one time A and B happened, right? A how many times? A 3 times, A occurred 3 times, B occurred 2 times. A occurred 3 times, B occurred 2 times. So now the equation is n factorial divided by 3 factorial into 2 factorial. So it means the first letter occurred 3 times, then we can divide it by 3 factorial. Second letter occurred 2 times, divided by 2 factorial. We don't need to put the C. C happened one time because 1 factorial is equal to 1. So it will not impact, right? So the equation says n factorial divided by 3 factorial into 2 factorial. So it means the common equation, let's say in your equations, n number of letters occurred more than one time in the sense, let's say maybe P1 factorial into P2 factorial into P3 factorial. So the meaning of it means P1 times A occurred, P2 times B occurred, maybe P3 times C occurs. Likewise, it will go. This is the common equation for this type of question. When the same letter occurred more than one times, and if you are making a word. So now tell me, here we have 6 letters, 6 factorial. A occurred 3 times, so 3 factorial into B occurred 2 times, 2 factorial. Even we don't need to worry about the C. Why? C occurred only one time. So if you want, you can divide 1 factorial. So 1 factorial is equal to 1. That's why I can ignore this one, right? So 6 factorial over 3 factorial into 2 factorial. So what is the answer for this? 6 factorial, 6 into 5 into 4 into 3 factorial. 3 factorial into 2 factorial is equal to 2 into 1. So 3 factorial we can cut down. Here 6 into 5 into 4 divided by 2. So what is the answer?
60.
60, right? So this is how we can find out the answers. Did you understand or not? What about others? This is the third type. Did you understand or not? Now I will explain with an example, then you can easily understand, right? So this type of questions, they are asking in different ways, right? They are not telling like these 3 A's, 2 B's likewise, right? So how they will ask this type of questions, right? Wait a minute, yeah. Okay, they will ask this type of questions. Okay, just read this one, right? Okay, now they are giving a word balloon, right? BALLOON. right? Now they are asking a question, how many distinct arrangements can be made from the word balloon? It means by utilizing the letters of balloon, how many words we are making? 7-letter words, right? So it means you need to utilize all the letters of balloon, right? You need to utilize all the letters of balloon and you need to make 7-letter words, right? So the question is how many distinct arrangements? It means how many unique arrangements we are making by utilizing these letters of the word balloon. Yeah, you can ask the question now. Maybe if I explain the question in different way, the question they are telling, you need to utilize the letters of word balloon and you need to make 7-letter words. How many 7-letter words we are making by utilizing the letters of balloon? Can you tell me the answer?
It's a 7 factorial.
What about others? At the end of the session, I will show you some past paper questions, right? So the first thing you need to find out how many words in this word balloon. Balloon, they have 7 letters, right? Altogether, we have 7 letters. Among the 7 letters, some letters are duplicate, right? If the word cannot contain any duplicating letters, different ways we can approach the questions. Let's say you have, let's say, okay, here this is duplicate, right? So just think about India, right? Now, 5 letters are different letters, right? India is the word India contains 5 letters. Each letter is a unique letter. Now my question is, by utilizing the letters of India, how many different words you can make? By utilizing the letters of India, how many words you can make? From the letters of India, how many words you can make without repetition? Here I need to mention, right? Why? There are possibilities while you are making the words, you can repeat the same letter again, right? So while you are generating the words, by repeating the same letter, you also make some new words, right? That's why I clearly mentioned in the questions, by utilizing the letters of India, how many words you are making without repetition. So what is the answer for this? I'm not telling how many letters you need to utilize. I clearly mentioned by utilizing the letters of India, how many words? It means you need to utilize all 5 letters, right? So the answer is, here we have 5 letters, 5p, 5. So 5 factorial. 5 factorial over 5 minus 5, not factorial. Not factorial is equal to 1. So 5 factorial. There are 120 words we are making. 120 words we can make by utilizing the letters of India. Now, if I ask the same question, you need to utilize all the letters of India. How many words we can make with repetition? With repetition in the sense the questions comes 5 to the power 5, right? Because there are 5 positions, 1, 2, 3, 4, 5. Altogether we have 5 letters. So it means the first position 5 ways, second position 5 ways, third position 5 ways, fourth position 5 ways, fifth position 5 ways, 5 to the power 5. 5 to the power 5 is the answers we are making the letters. But now the question is a little bit different. Previously, each letter is a unique letter. If you look at this type of scenarios, the L, the same letter happened 2 times, or the same letter happened 2 times. So this type of questions, first thing we need to find out, there are 7 letters. Is there any letters are duplicating? L occurred 2 times, L occurred 2 times, O occurred 2 times, right? So the equation says n factorial over 2 factorial into 2 factorial. N means altogether 7 words, 7 letters, 7 factorial divided by 2 factorial into 2 factorial. So the answer is 7 factorial divided by 2 factorial, 2 into 2, 4. So what is the answer? 7 into 6 into 5 into 4 into 3 into 2 into 1 divided by 4. We can cut down these two 4s. So the answer is 7 into 6 into 5 into 3 into 2, 6. So 6 into 6, 36. 36 into 7 into 5, right? So the answer is 36 into 7 into 5. So we can write 18 into 2, 18 into 7 into 10, right? So then I think these number of options, right? Sorry, I did a mistake, right? You can find out the answer. 36 into 7 into 5. 36 into 7 into 5. So 36 we can write 18 into 2. 18 into 7 into 10. So 18 into 7, 70 plus 56. How many? 6, 120, right? 126 into 10. 1260 words we are making, right? So this is how we can find out the answer for this type of questions. Any questions? So it means you need to think about all the words, how many words duplicating. By that duplicating word counts, we need to divide, right? Okay, now I am asking another questions, right? You have a word telecommunications. Okay, now how many unique distinct words you are making by utilizing the letters of telecommunication? Tell me. So how many words we have? 2, 4. How many letters we have? 2, 4, 6, 8, 10, 12, 13, 14, 15, 16, 17 letters. Altogether we have 17 letters. So now tell me how many words are duplicating? How many T's we have? How many T's? 1. How many T's we have? 1, 2 T's, right? There are 2 times T occurred. How many E's we have? 1, 2, 2. How many L we have? Only 1, right? So you don't need to worry about L. So how many C's we have? How many C's? 1, 2, 2 C's. How many O's? How many times the letter O occurred? 1, 2 times, right? How many M's? 2 times. How many N's? 1, 2 times. How many I's? There are U is there, right? Only one U, so you don't need to worry about that one. So here we have only one, yeah, only one U is there, so we can ignore the U, right? How many I's? We have 2 I's. How A is there? Only one A is there. A we can ignore, right? How many C's we have? Already C we considered, right? If you look at this one, 2, 4, 6, 8, 10, 12, 14, 15, 16. Another one letter is missing. Which one?
L.
Yeah, L is there. L is only 1 times, right? So altogether 17 letters there are 1, 2, 3, 4, 5, 6, 7. 7 letters 2 times occurred. So 7 into 2, 14. Here 15, 16, 17, right? So how many unique words you can make? 17 factorial divided by 2 factorial into 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 2 factorial. 7 times we need to divide. 1, 2, 3, 4, 5, 6, 7 times into 2, right? So this is the number of words we are making, right? Because 7 letters, they have more than 1 occurrences, right? So it means 17 factorial divided by 2 factorial, 2 factorial, 2 factorial, up to 7 times we need to divide. This is how we can find out the answer for this type of questions, right? Okay, these are the 3 types we are utilizing for permutations, right? Now we are moving for the combination type questions, right? So now we will look at how we can, what are the equations we have for combination type questions, right? Any doubts up to permutations? So these are the different types of questions we need to consider in permutations, right? Now we will move for the combinations. Any doubts? So you have only 3 different types of questions I will explain, right? With repeat, without repeat, the same letter occurred more than 1 times, you have different equations, right? So this is what we are discussed up to these, right? Okay, now we will move for the next type, that is a combination, right? So if it is a combination, we are not giving order, we are not giving priority for order of elements, but we are giving the selection of elements, right? So which elements we are selecting gives more important in combinations, right? So already last class I explained the equation for combination, right? Yeah, the equation says n objects. From the n objects, I need to select r objects to make a group, right? That's the thing. If you want to make a group, from the n objects, we need to select r objects. So the equation NCR, n factorial over n minus r factorial into r factorial. So n factorial over n minus r factorial into r factorial. This is the equation for combination we are utilizing, right? So a combination is a selection of objects without considering their order, right? The combination where we can utilize while making some teams. While we are making some teams, we are not consider which order we are selecting the elements. We only consider who are the people included that group, right? So that is a simple example. If you are making a group for a competition or for a something, we are not consider who are the one we are selecting as a first guy, who are the one we are selecting the first guy, second guy, third guy. We are not consider the order of element we are selecting. We only consider who are the people included in this group, right? This type of questions we are consider combination. So combination means without selecting the order of element, we only consider who are the people selected to the team. That type of question we are consider as a combination questions, right? So this is the equation NCR, n factorial over n minus r factorial into r factorial, right? Not only combination, we are utilizing this equation for some different scenarios, right? I will explain, right? You know something called binomial theorem, right? So it means, let's say, I will explain later. A plus b whole thing to the power of 2 is equal to a squared plus 2ab plus b squared, right? Let's say a plus b whole thing to the power of 3 is equal to a cube plus 3a squared b plus 3ab squared plus b squared.
BQ. So
Sorry, a cube, yeah. A cube plus 3a squared b plus 3ab squared plus
BQ.
b cube, right? Now tell me what is the equation for a plus b whole thing to the power of 4? How we can write? If you want to find out these what are the elements are coming, we are utilizing these equations, right? This NCR concept is more important to find out these, right? I will explain a little bit later that one, right? First, we will look at these, the combination, then this is the application of combination. This is the application of this equation, NCR, right? Okay, I will explain later, right, this one. So now we will move for the combination. So combination equation is this one, right? I will explain one example, right? So this example says from 5 students, right? There are 5 students in a classroom, right? We need to select 2 students as a prefect, right? How many possible ways you are selecting these 2 prefect? Just think about, there are 5 students, S1, S2, S3, S4, S5. There are 5 students in a classroom, right? I need to select 2 students as a team lead or whatever. Maybe I'm selecting 2 students as a monitors or prefect from these 5 students, right? Now tell me how many possible ways you are selecting. It means how many options you have to select these 2 students. Tell me, there are 5 students. From these 5 students, you need to select 2 students as a prefect for that classroom. For the 5 students, you are selecting 2 students for something, some purposes. Let's say there are 5 students. I need to select 2 students and I send these 2 students for a mathematical Olympiad exam or something. Just think about, from the 5 students, I need to select 2 students and send them to a competition. So how many options I have to select these 5 students? How many options means how many possible ways I can make this group, 2-member group.
20.
So the easiest way, right, you can utilize this equation, right? We have 5 students. From these 5 students, I need to only select 2 students, 5Z2, right? If you are utilizing the equation, from n number of objects, we are selecting R objects and make a group, that is NCR, n combination R, right? So how we can find out whether we are consider NCR or NPR, right? The question says only they need a 2-member group, right? They are not consider which order they are selecting the students. They need who are the members of the group. That is the thing. This question they are telling, right? In this question, from 5 students, how many ways you can select 2 students for a committee? For a committee, you need to select only 2 students from 5 students. So what are the possible combinations we are making these 2 student group? So it means you decide. So here they are asking the question, what are the all possible ways I can make this group? They are not consider which order I am selecting the group. Only the question they are asking, what are the possible groups I can make? What are the possible groups I can make? They are not consider which order I am selecting. Let's say if I selecting student 1 and student 2, that is a one group. We cannot say student 2 and student 1 is a different group, because student 1 and student 2, let's say if I make a group with student 1 and student 2, another guy, he cannot say student 2 and student 1 is a different group. Why? These 2 groups contain the same students, right? So in this type of scenario, we consider these 2 as the same group, because these 2 groups contain the same student 1 and student 2. So in permutation, we consider this is a separate count, this is a separate one, right? But in combination, we consider these 2 as the same. Student 1 and student 2 is same in group 1 and group 2, right? So this is how we can decide which type of equation we can put, right? So here 5C2 in the sense, from 5 objects, we need to select 2 objects, right? So 5 factorial over 5 minus 2 factorial is equal to 3 factorial into 2 factorial. So 5 factorial, 5 into 4 into 3 factorial. divided by 3 factorial into 2 factorial. 3 factorial, we can cut down. 5 into 4, 20. 20 divided by 2 factorial is equal to 2. There are 10 ways we can make the groups, right? Can you write all the 10 ways? Is it possible to write all? Someone? Can you try this?
Can you repeat the question, sir?
No, I need, we have find out the answer as a 10, no? So 10 ways we are selecting the group. So can you make all the 10 groups from this student 1, student 2, student 3, student 4, student 5?
Yes.
Okay, I will explain, right? Just look at here. If I take the student 1, I can make 4 other groups. This is one group, this is another group, this is another group, this is another group, right? So it means, let's say with student 1, student 2 is a one group. Student 1, student 3 is another group. Student 1, student 4 is another group. Student 1, student 5 is another group. So here we have 4 groups. Student 1, with student 1, student 2 is maybe student 1, if I take student 2, one group, 2 group, 3, altogether we have 4 groups here, right? Now, if I take with student 2, I cannot make a group with student 1 again. Why? Because I cannot take this one and make a group. Why? Already student 1 and student 2, they are considered as a one group. Right? So now how I can make the group with student 2, maybe I can create a group student 3, student 4 as a group, student 5 as a group, right? With student 2, student 3 is a group, student 2, student 4 is a group, student 2, student 5 is a group. Maybe you can check and let me know if any groups duplicate the same students again and again. If you look at here, we have 4 groups are there. Here we have 3 groups are there. The third one, if you consider with student 3, I cannot make student 3 with student 1 because student 3 and student 1 already I have a group. Student 3 and student 2 already I have a group. So student 3 I can make one group this one group this one. Student 3, student 4, one group. Student 3, student 5 is another group. Here we have 4 groups. Here we have 3 groups. Here we have 2 groups. So altogether 9 groups, right? Another one group with student 4, we are making only student 5 because already student 1 and 4, one group. Student 2 and 4, student 3 is there. So student 4 and 5, we are considered as a one group. Student 4 and student 5, we are considered as a one group. If you take student 5, already student 5 and student 1, we have a group. Student 5 and student 2, we have a group. Student 5 and student 3, student 5 and student 3, we have a group. Student 5 and 4, already we have a group. So altogether, 4 plus 3 plus 2 plus 1, altogether we have 10 groups, right? So these are the unique 10 groups we are making in combination, right? This is the answer 10 we are getting, right? If you look at this example, right, there is a relationship between the permutation and combination, right? So permutation in the sense, here we have 10 groups. We are making another 10 groups in different way. How we are making another 10 group, right? These are, did you agree with me? These are the 10 unique groups. It means no any group duplicate the same 2 students again and again. Do you agree with me? Give me a minute. Yeah. Do you agree with me? These 10 groups are unique groups. First tell me, do you agree with me? These 10 groups are unique or not? Unique in the sense, each group, they are not duplicate the same student again. Do you agree with me?
combination is possible.
Yeah, it means these are the 10 unique groups. Did you agree with me? Or someone tell me, you can tell some other examples or some other group combinations. Tell me. I am telling you, these are the all possible 10 groups. Do you agree with me?
Yeah.
What about others? What about others? Tell me. So these are the 10 unique groups, right? The relationship between permutation and combination, right? If it is a combinations, we are not giving the priority for order of elements, right? But if you think about permutation, right? If you think about the permutation, this S1 and S2 is we are considered as a one group. S2, S1 we are considered separate group. S3, S1 as a separate group. S4, S1 as a separate group. S5, S1 as a separate group. Similarly, S3, S2 as a separate group, S4, S2 as a separate group, S5, S2 as a separate group. Here also, S4, S3 as a separate group, S5, S3 as a separate group. Similarly, S5, S4 as a separate group, right? So altogether, if you take the sum of these, we have 20 options, 20 groups when it is a combination. Sorry, it is a permutation. Permutation in the sense we are giving priority for order of making the groups, right? So if it is a permutation questions, we have altogether 20 groups, right? Now tell me the same questions, right? There are 5 objects. Student 1, there are S1, S2, S3, S4, S5, right? From these 5 objects, how many permutations we are making with maybe two objects? So it means 5P2. 5P2 is equal to
60.
5 factorial over 5 minus 2 factorial is equal to 3 factorial. 5 factorial over 5 minus 2 factorial is equal to 3 factorial. So 5 into 4 into 3 factorial. So 3 factorial we can cut down, right? So 5 into 4, 20 permutations. So what are the 20 permutations? These are the all 20 permutations. Here 10 is there, here 10 is there. But if you think about combination, right, we are considered this one and this one as a same, right? This is the relationship. This one and this one we are considered as a same. This one and this one same. This one same. This one same. So now you can clear the difference between permutation and combinations. Am I correct? So the order of the element, if you give priority, that is we are considered as a permutation. We are not consider order of the element combination. Without priority for the order of the element, that is combination. With priority for order of the elements, that is permutations. That is the difference between permutation and combinations, right? Any questions? So this is explained through these points, right? You can read and try to understand, right? They are explaining these throughout these relationship between permutation and combination. The same explanations they are giving here also. Any questions? Give me a minute. So you can read and understand the relationship between these, right? So you can read the relationship, what they are telling. Permutation is a combination multiple by number of ways to arrange the selected objects. So just you can read and try to understand these, right? Yeah, just try to understand these, okay? So it means there is a relationship. The order of the elements impact in permutation and combinations, right? Okay, now we will applications of counting techniques. We will look at what are the applications of these counting techniques. What are the different places we can utilize these permutation and combinations, right? So just you can read these, right? Counting techniques are specially utilized in different places, right? In various fields, we are utilizing these counting techniques, right? So the password making, scheduling, right? Computer science, arranging passwords, right? While you arrange the passwords, we utilize these counting techniques to check all the possible combination of passwords, right? Scheduling algorithm schedulings also we consider, right? You have something called operating system in your upcoming semesters. At that, you can schedule the task, right? The priority scheduling, round robin scheduling. There are different types of schedulings are there. At the time also, you can utilize these counting techniques, right? Probability calculations also we utilize these counting techniques, right? Maybe you have subject called probability. I think if you have on that, you can learn these things where we can apply these counting techniques. Not only that, we will discuss some probability content, right? So to calculate the probability, we utilize these counting techniques, right? So at the time, I will explain how we can utilize counting techniques in probability also, right? There are different places. The key generation, right? Crypto, you have a subject called network subject, cryptography, encryption, decryption. On that also, we have utilized these counting techniques, right? Okay, we will look at one example. Then, yeah. For example, one, a server has 4 different tasks, right? Just think about there is a server computer is there. For the server computer, we have 4 tasks. Task 1, task 2, task 3, task 4, right? This one application question. A server has 4 different tasks to be executed sequentially. Sequentially means one by one. It means we need to, there are 4 tasks to complete, right? We need to give these tasks one by one. That is the meaning of sequentially, right? Concurrently means at a time we will give all 4 tasks to the server. This question is, we need to give the task one by one. After completion of one task, we can give the second task. After completion of second task, we can give the next task, third task. After completion of third task, we will give the fourth one, right? Likewise, we will give. This is the meaning of this sequentially. In how many different orders can these tasks can be scheduled? This is the question. There are 4 tasks, task 1, task 2, task 3, task 4, right? Now, how many different ways you can schedule these tasks? Now tell me what type of question this one.
Permutation.
What about others? What about others? It's a permutation or combination. How we can decide for this question it's a permutation or combination?
The terms of sequence.
The terms of sequential. The meaning by one in the sense they are giving high priority for order, which order we are providing the task, right? So based on that term sequentially, we can take a decision. This is a permutation question. This is a permutation question, right? This is how we can take the decision based on the question, right? Now what they are telling. So now we can find out permutation. So in permutation, which type of permutation? This one, whether repeated with
Not
repetition or without repetition.
without repetition.
Without repetition, because here we have 4 different tasks, right? We cannot duplicate the task again. So repetition means the same task occurred more than one time. That is the meaning of that one, right? The same task occurred more than one time. That is the repetition. It means the same task T1, we can, let's say, first we can complete the first task. Again, we will provide the first task. That is worst case, right? There is no any meaning. If you complete the task 1, again we are giving the task 1 is a meaningless, right? That is a resource wastage, right? For the server, first we are giving, just imagine you are giving task 1. Again, you are giving the same task in the sense already the task 1 is completed. So that is a worst case scenario. That is a resource utilization is worst case, right? It means that is a, there is no any use. Again and again you can repeat the same task. So this is not a repeated question. With repetition, we are not utilized. So the only equations NPR. So we have 4 distinct tasks. Now we have another questions. How many? The R is how many? So altogether we have 4 tasks. So how many? What is the value for R? N we are decide. N means total number of tasks. We have 4 tasks. So what is the value for R?
It's also 4.
It's also 4. Why it's also 4? In the server, we need to utilize all 4 tasks one by one, right? The thing is, we need to pass the 4 tasks one by one. So it means from 4 objects, we are utilizing all 4 objects to make the order. So that is a question. What are the different orders you can input the task to the server? It means we need to consider all 4 tasks one by one. So the question is 4P4. So 4 permutation 4 means 4 factorial over 4 minus 4, 4 minus 4 factorial. So 4 factorial over not factorial is equal to 1. So 4 factorial means 4 into 3 into 2 into 1. So it means 24 ways we are making the task, right? It means there are 24 possible combinations, 24 possible orders we are making for these 4 tasks, right? For these 4 tasks to complete that server sequentially, 24 alignments possible, 24 combination possible. What are the 24 combinations? T1, T2, T3, T4, T1, T2, T4, T3, right? Then T1, T3, T4, T2, T1, T3, T2, T4, right? T1, T4, T2, T3, T1, T4, T3, T2. So altogether how many here? 1, 2, 3, 4, 5, 6. I am taking first element as a T1. I am making 6 options. Similarly for T2, I can make 6 options. Similarly for T3, I can make 6 options. Similarly for T4, I can make 6 options. So altogether 6 plus 6 plus 6 plus 6, 24. This is how we can write all possible 24 combinations, right? Hope you can understand, right? Any questions? Anyone have any doubts? Definitely we have one question for your final exams, right? Try to understand these. That's why I'm telling. Try to understand these. Anyone have any questions? Okay, the next question, right? A system password consists of 3 different letters, right? It means there is a system password generated, right? With three letters, three different letters. Try to understand. Three different letters. What the meaning of three different letters? Why they are putting these three different letters? They have some meaning. From 5 letters A, B, C, D, E, right? Altogether, we have 5 letters. From these 5 letters, we need to make 3-letter passwords, right? But they are clearly mentioned 3 different letters are chosen. What is the meaning of this one? 3 different letters. They have some meaning. That's why they are clearly mentioned 3 different letters. The meaning of 3 different letters in the sense without repetitions, right? The meaning of 3 different letters means you need to consider without repetition, without repeating the same letter. That is the meaning of that one, right? So from 5 letters A to E, A, B, C, D, E, they are creating 3-letter passwords with different letters in the sense we are not utilizing n to the power r equation. Why? When we are using n to the power, that is the repeat also possible. The same letter we can utilize again and again to make the passwords. But they are clearly telling, we need to utilize 3 different letters, right? So what is the equation for that one? From 5 letters, we need to make 3-letter password in the sense 5p3. 5 factorial over 5 minus 3, 2 factorial. So 5 into 4 into 3 into 2 factorial. So 5 into 4 into 3, 60 passwords we can make, right? 60 passwords we can make from these 5 letters, right? Any questions?
Excuse me, sir.
Yeah.
So can you slice the exercise 2 questions, that the second question for the math?
Okay, yeah.
That
Okay, now we will
question.
look at, okay, we will look at one by one, yeah. If you have any doubts, maybe you can ask. Otherwise, I will explain the exercise questions. Okay, we will move one by one, right? Now, the first question, just the description, right? You need to differentiate what is the difference between permutation and combinations, right? So order is important, that is a permutation. Without considering the order, just selecting the elements, that is a combinations, right? Now, the question number 2, that is an exercise questions. How many 4-letter words with or without meaning can be formed from the letters of words math? Right? So the letters of math in the sense, there are 4 letters, right? So if you look at here, the first thing you need to think about, is there any duplicate? The letters are repeated. It means there are any more than one occurrence of letters. It means 1M, 1A, 1T, 1H. So we are not considered third permutation for this question, right? The question is, how many 4-letter words? Right? This question, it includes 2 things, right? With or without meaning. What do you mean by that?
Means, am I right that with means without repetition, without means can we do the repetition? Am I right, sir?
Yeah.
Okay.
Okay, it means in these questions, I'm asking 2 things, right? Yeah, wait. How many 4-letter words with or without meaning? So what is the meaning of with or without meaning? That is the key thing here. In this question, I'm telling with or without meaning. That's the key thing. What is that? So now you
My
decide
answer
that
is
this.
right, sir.
Sorry?
My answer is right. That for without this means usual permutation method, with means like the into the method.
No. Here
Yeah,
what they are telling.
word வந்து meaning அல்லது meaning இல்லாம அப்படியா?
Yeah, what they are telling, you don't need to worry about the word is meaning or meaningless, right? So what they are telling with the word is meaning or meaningless means they are trying to telling, right? Maybe you can make a word this one. That's also possible, right?
Oh,
So what they're
என்னன்னு
telling, you
சொன்னா,
don't need to worry about the meaning of the words, right?
without meaning என்று சொன்னா சார் அது இது ஆர்டர் மாறலாம், இது ரிப்பீட்டேஷன் வரலாம் தானே சார்?
Oh, without meaning சொன்னா repetition வரலாம்.
வரலாம், வித் என்று சொன்னா வராம செய்யணும், ரெண்டும் செய்யணும்.
இல்ல அப்படின்னு இல்ல with repetition சில கொஸ்டின்ஸ்ல கிளியரா மென்ஷன் பண்ணுவாங்க, ரைட்? ரிப்பீட்டேஷன் அலௌடா இல்லையான்னு சொல்லி. இப்போ இதுல சொல்லப்படுது என்னன்னு சொன்னா ஜஸ்ட் ஃபார் இன்ஃபர்மேஷன், உங்களை குழப்பறதுக்காக, ஜஸ்ட் ஃபார் கன்ஃபியூசிங் யூ, தே ஆர் டெல்லிங் with or without meaning, right? So it means you don't need to worry about the meaning of the words, right?
மீனிங் எடுக்காம செய்யலாம்.
Oh,
Okay.
why they are telling this one? Sometimes some students, right, they will write only meaningful words, right? So why they are telling you don't need to worry about the meaning of the words, right? Just you need to make the words by utilizing the 4 letters of these, right? So these 4 letters are unique letters. Now you have a questions, right? You can answer the 2 questions. One, maybe you can answer with repetition. Now tell me what is the answer for with repetition? What is the answer for with repetition? How
With
many
is,
words?
256.
Yeah, it means we can say with repetition means 4 to the power. We have 4 letters, right? N is equal to 4. By utilizing all 4 letters, 4 to the power 4. So it means 256. 256 words we are making with repetitions, right? Now tell me without repetition. Without repetition, how many words we are making? 4p
4.
4, right? So 4 factorial over not factorial. So 4 into 3 into 2 into 1. So it is equal to 24 words, right? Now tell me, right, how many words with repeated letters? Tell me how many words you are making with repeated letters. It means, for example, how many words they are containing this one, or maybe MMAH. Likewise, more than one letter occurring words, how many? How many words it contain repeated letters? Maybe I have not mentioned exactly how many repetitions. More than one letter repeated words are how many?
6.
Based on this one and this one, you can tell me the answer. You can easily
256.
find out.
232.
What about others? So what we need to do, with repetition we have 256 minus without repetition 24. So the remaining 256 minus 24, 232 words. 232 words, they have repeated letters in the 4 letter words, right? So only 24 words we can make without repetition. So with repetition we are making 256. So 256 minus 24, 232 words, they have more than one repeated letters, right? So if you want to understand this, you can easily check with the ABC, the previous example, right? I explained with ABC. From this ABC, with repetition, how many 2-letter words we are making? Without repetition, how many 2-letter words we are making? Then you can easily find out how many words they are duplicating the letters, right? This is how we can easily find out. Try this. Already I will explain, right? With repetition, how many 2-letter words? Without repetition, how many 2-letter words? Then you can write all the with repeated words, without repeated words. Then you can subtract, then you can easily find out how many words they are containing repeated letters, right?
Excuse me, sir.
Yeah.
அந்த மெத் அந்த கொஸ்டினுக்கு வந்து நம்ம ரெண்டு ஆன்சரும் கொடுக்கணுமா அல்லது வந்து
No,
இந்த
pretty
மாதிரி
question நீங்க ரெண்டும் you need to give two answers, right?
வித்துக்கும் வித்தவுட்
With you need to tell with, because they are not clearly mentioned with repetition or without repetition, right? Then you can give these. Most of the time this is exercise, right? So but for your final exam we are clearly mentioned, right? Here why I am not mentioned, you need to practice both, right? So what I need, that thinking, right? So what I'm expecting from you, your thinking capability, whether we need to think about with repetition or without repetition. Maybe if you are not think about these, whether there are two options we have, which one is coming. If you can't think about that way, you are not under track, right? You are not catch the subject. That's the meaning of that one. If you understand the subject, you will definitely tell which one, with repetition or without repetition. Otherwise you are not telling, otherwise you don't have a confusion. That's the thing, right? Okay, the third question, right? In a bookshelf, right, there are 5 books. How many ways you can arrange them? In how many ways can 5 books be arranged in a bookshelf? So which type of question?
permutation.
Permutation. Why? While if you look at the library, while you are arranging the books, you have some specific order, right? We will arrange. In a bookshelf, the order of the elements we arrange the books are important. So it's a permutation questions, right? Is it possible to repeat the book? This is how you can answer, right? Is it possible to repeat the same book? Because we have only one copy of the book, right? So we cannot take that particular book, history book, in the first position and third position. Is it possible? You can't, right? Because you have only one copy of each book. So either if you put the first position or second position or third or fourth or fifth position, we cannot repeat the same. So this is not a repeated, with repetition, this is not possible. So the answer is NPR. We have 5 books. From these 5 books, we can arrange the 5 books in a cell, 5p5 in the sense, 5 factorial over 5 minus 5 not factorial. So 5 factorial is the answer. It is 120 ways we can arrange these 5 books in a shelf, right? That's the thing. 120 ways we can arrange only the 5 books. Only 5 books we arrange in a shelf in 120 ways. Just think about. Okay, the fourth one. What is the fourth one? Fourth question. So the simple way, the first position, how, let's say we have 5 books. Just think about, we have 5 books. The first position we can fill 5 ways, right? So already if I fill the first position, for the second position I have only 4 books. So the 4 ways. For the third position, already I have filled the first position and second position. Now for the third position, I have 3 books. 5 into 4 into 3 into 2 into 1. So altogether 20 into 60, 120 ways, right? This is also one way you can answer the questions without considering the equations. Okay, the fourth one. A committee of 3 students is to be formed from a group of 7 students, right? There are 7 students. From the 7 students, we need to make a committee of 3 students. How many possible committees can be formed? How many possible committees? How many possible options to form this committee? That's a combination, right? Because we are not, while we are making committees or groups, we are not consider which order we are making the committee. We only think about who are the people included in the committee, right? So that is a combination question, 7 C 3. So 7 factorial over 7 minus 4, 3 factorial is equal to 4 factorial into 3 factorial. So 7 into 6 into 5 into 4 factorial, 4 factorial, we can cut down. 3 factorial, 3 into 2. So 3 into 2 into 1, 6, we can cut down. So altogether 35 ways we can make, right? Okay, now the fifth one. How many distinct permutations can be made from the word success? Right now the question is how many the letters are duplicating. How many S we have? altogether 7 letters. From the 7 letters, there are 3 S's, right? 2 C's. There are 3 S's and 2 C's, right? So how many distinct words we can make? 7 factorial over 3 factorial into 2 factorial, right? You can find out the answer, right? Okay, the 6th one. How many 3-digit even numbers can be formed using digit 1, 2, 3, 4, 5? This is something different, right? I will explain this question.
Excuse me, sir.
Yeah.
And so now the review question based பண்ண அந்த அளவு டஃபா தான் பாஸ் பேப்பர் வரும் அதோட கொஞ்சம் அட்வான்ஸ் ஆகுமா நம்மளோட கைட்
விளங்கல
நம்மளோட பேப்பர் ஃபைனல் எக்ஸாம் பேப்பர் இந்த ரிவ்யூ கொஸ்டின் பேஸ் பண்ண அந்த
பாஸ் பேப்பர் செக் பண்ணுங்க ரைட் நான் ஒரு பாஸ் பேப்பர் क्वेश्चन உடனே எக்ஸ்பிளைன் பண்றேன் ரைட் ஒரு 5 மினிட்ஸ் தாங்க எக்ஸ்பிளைன்
பாஸ் கொஸ்டின் எல்லாம் அந்த காம்பினேஷன் எல்லாம் டபுள் அண்ட் போட்டு செய்வது கொஞ்சம் அட்வான்ஸ் ஆயிருக்கு சோ அதான்
கொஞ்சம் அட்வான்ஸா தான் வரும் ரைட் நான் ஒரு கைடு ஒன்று சேவ் பண்ணுவேன் இந்த சப்ஜெக்ட் முடிஞ்சதான் இன்றைக்கு சோ அதுல கொஞ்சம் அட்வான்ஸான क्वेश्चंस இருக்குது ரைட் அதை பிராக்டீஸ் பண்ணி பாருங்க ரைட்
சரி
okay the 6th one right how many 3 digits even numbers this is a key thing right so now you need to make 3-digit even numbers can be formed using the digits 1 2 3 4 5 right okay you have 1 to 5 the digits right now they are telling no repetitions right so there is no any repetition they are allowing right now tell me how we can find out the answer for these there are 1 2 3 4 5 there are 5 digits right the question is okay now tell me how many numbers 3-digit numbers you are making from these 5 from the 5 digits so n is equal to 5 how many 3-digit numbers you are making tell me the first that one so the question is a little bit complex here right that's why I'm telling you have 5 digits from the 5 digits 3-digit numbers how many you are making without repetition so first thing this is a permutation question right because right let's say 1 2 3 is a one number right 2 3 1 is a different number 3 2 1 is a different number the order how we can arrange the elements impact the order how we can arrange the element impact the different numbers it means the same 1 2 3 how we are arrange these 3 in a position 3 different position we are making 3 different numbers so this is a permutation question right so now tell me if you have 5 digits from the 5 digits how many 3-digit numbers you are making 5p3 so how many 5 factorial over 5 minus 3 factorial 5 minus 3 factorial so it is equal to 5 factorial over 2 factorial to 2 factorial so 5 factorial is 120 2 factorial is 2 altogether 60 numbers we are making but the question is different what is that what is the question here altogether from 5 digits we are making 63-digit numbers but the question is a little bit different what is the question is
5p2 for the even number
so how we can make even numbers so if a number is even number how we can say now tell me let's say I'm making a number 1 2 5 is a even or odd number
odd number
why the last digit is 1 so definitely if I divided by 2 the remainder is 1 right similarly let's say I'm making another number 524 So this is a even number. How we are showing is a even number?
Divided by 2 is
So the last digit, based on the last digit, we can decide whether even number or odd numbers, right? So how we can find out how many even numbers we are making utilizing these? So total we can make total we are making 60 numbers by from the 5 digits, 3-digit numbers we are making 60. Altogether 63 digit numbers we are making, right? Now my question is, just think about this is the 3 digits, right? So for this type of questions, we don't have any equations, right? So for this type of questions, we don't have any equations. But anyhow, we need to find out the answers. So how we can find out the answers? Now tell me, yeah, someone raise the hands. Yeah, give me 5 to 10 minutes, right? So I think you have another next lecture is 1 o'clock, no? So now tell me, what are the possible numbers for the last digits?
2 and 4.
So if you want to
possibilities.
make even number, only here we have two numbers, 2 and 4, right? So here, how many possibilities we can make? If you want to make even number, the last digit either 2 or 4. These are the only two options we have. Am I correct? So now tell me, how many possible ways we can fill these? How many possible ways we can fill these?
Two for the last digits, sir. You asking?
Yeah.
For the 2.
Okay, for this, we have two possibilities. Either there are two ways we can fill, either 2 or 4. Now tell me how many possible ways we can fill this. How many possible ways we can fill the first digit?
4.
5.
4. I think. 4.
How many possible ways we can fill the first digit? 5 or 4?
4.
4, sir.
What about others?
Four.
How many? Tell me. Okay, there are different ways to find out the answer. One way, right now tell me from these 5 digits, how many 2-digit numbers you are making? Tell me. There are different ways we can find out the answer, right? Okay, we will approach the first way. How many ways you can fill these, the first position?
First means 100 or 10, sir.
Sorry, it means, let's say these are the 3 positions, 1, 2, 3, right? The first positions, how many ways you can fill?
4, 3, 2.
So it means what are the numbers we are putting for here? Altogether we have 5 digits, right? Altogether we have 5 digits, right? From these 5 digits, how many possible ways we can fill here?
4.
What about others? Why you are telling 4?
It's a 100 position.
Yeah,
So
5 or
let's
4?
check. 4. 4 and the 10 to the position should be 3. One's position should be 2. Because total digits is a 5.
What about others? Five is wrong. Why? We cannot fill the last position as a 5 different ways. Why? Why is not coming 5? We have digits 1, 2, 3, 4, 5, right? If you have a 5 option, what will happen? Just think about you put 2 or 4. Let's say if it is a 5 option in the sense, here we can put 2 or 4 in the first position also, right? But that is not possible. Why? If you put 2 or 4 in the first position, what will happen? You are not getting
Repetition.
even number, right? So from the 5 digits, only 4 digits are possible for the first position. Why? Only 4 positions are eligible for the first position. Why?
The
Among
repetition.
these 5 digits, definitely one even number we can give for the last position, right? Then only it must be a even number. Otherwise, what will happen? It must be a odd number also possible, right? So the first position we can fill 4 ways. How about the second position?
3.
How about the second position? They are clearly mentioned. We cannot repeat the same. So already if you fill one position, 4 positions, the second position also we have
3. Because 2 even number we have at in the corners. So we have the odd numbers balance 3.
What about
1,
others?
3,
3.
What about that? I don't know what about others. Did you understand or not? Okay, I will finish, right? Give me 5 minutes, right? Okay, then, right, the next class, I will ask you this one as a first thing, right? So everyone try to explain this question. I don't need the answers, right? I need an explanation, right? Before I apply, before I tell the answer, right? I need the explanation how you are selecting the positions. That is what I need, right? Even if you are confusing, right? We already find out from the 5 digits, if you want to make 3-digit numbers, there are maximum of 60 numbers we are making. Either you can write all